Hello everyone. Till now in the unit of kinematics, we were discussing all the concepts of motion when the body was moving in a straight line. That is, we always considered the motion in a straight line for all the equations of motion, or for any graphs which we have discussed. We have always considered the motion to be in a straight line. Now the time has come when we should discuss the motion in a plane. That means in 2 dimensions we will be considering the motion. Now to have the motion in 2 different directions, like to have the motion in a plane, we need vectors. These vectors becomes very important when we are considering the motion in a plane. So first of all, we are going to discuss what vectors are. Vectors are actually the representation of vector physical quantity. So I am going to discuss in this video the very basics of vector. So go through the video very carefully. Now here you see, we all know that the quantities can be divided, all the physical quantities can be divided into 2 parts. One is scalar and another is vectors. So just to remind you, the scalar quantities, the physical quantities which have only magnitude and no direction, are called scalar quantities or scalars. A scalar quantity can be specified by a single number along with a proper unit. Like some of the examples of scalar quantities are given here, like mass, volume, density, time, temperature, electric current, etc. These are scalar quantity. Let us take an example. Suppose mass of a body is say 5 kg. So 5 is the numerical value followed by its unit. But there is no direction. 5 kg doesn't have any direction, so it is a scalar quantity. All the quantities which are mentioned in the let us take an example of time. Suppose 10 minutes is the time. So if 10 minutes is the time, it doesn't have any direction. It has a value followed by its unit. It doesn't have any direction. So it is a scalar quantity. Next, vector quantities. I hope scalar quantity is clear to everyone. Now, vector quantities, as you all know, vector quantities are the physical quantities which have both magnitude and direction, okay, and obey the laws of vector addition, are called vector quantities. Now you must be thinking, what is the laws of vector addition? This laws of vector addition you have not done till now, okay, but in this chapter only we will be discussing this laws of vector addition. So all the vector quantities actually follows the laws of vector addition. So to basically define a vector quantity is the quantity which has magnitude plus it has directions also. Now some of the examples are given here, like displacement, velocity, force, momentum. Displacement, distance traveled in a particular direction is displacement. Like suppose the distance traveled is 5 meters towards west. So if we add this towards west, then this becomes the displacement, which is a vector quantity. Similarly, force. Suppose a body is being pulled by a force of say 5 newtons. So the direction of force along with the value, that is 5 newton, this makes the force complete. Like if you just say the force is 5 newton, the information is not complete. You have to consider the direction also to specify any force. So vector quantities are those quantities which have magnitude as well as direction. Now the question is, how do we represent vector quantities? Now vector quantity is represented by a vector. Now what is a vector? Now vector is a line which has an arrowhead. That means a vector quantity is represented by a straight line with an arrowhead over it. The arrowhead shows the direction and the length of the line shows the magnitude. Just see the diagram here. From the tail to the head, the length here represents the magnitude of the vector quantity, and the arrowhead here shows the direction. So a vector quantity can be represented by an arrow. The length of the arrow will give you the magnitude of the vector quantity, and the direction of the arrowhead will give you the direction of that particular vector quantity. Let me further explain you a bit. See here. Suppose we want to represent a force. Let me draw an arrow which represents a certain force. Say the value of force here is given by F, which is equal to, let's say, 2 Newton. And what is the direction of force? We have to mention it also along, say, x-axis. So along x-axis represents the this arrow, which is a vector. It represents the vector quantity force, which is of 2 Newton along x-axis. Now see, the length of the line here, that is the length of the arrow, represents the numerical value, that is 2 Newton, and the arrowhead represents the direction. Now suppose you have to represent 4 Newton force in the same x-axis direction. What you will do? Now the arrow, the length of the arrow will be double of the length which we have just now considered. Let's say this be the length. Now here the value of force is double. That is, the value of force which we are now considering is 4 Newtons. Okay, and again the direction is x-axis. So we have to write or mention the direction always, because it is a vector quantity. Now you can see here also the length represents 4 Newton, which is double of 2 Newton. So if we have represented a vector for 2 Newton, and accordingly we have to make represent the same physical quantity of force by another vector where the magnitude is now double, so the length of the arrow gets double. And since the direction is same here, so it is, we have written here x-axis. So always remember, when we represent a vector quantity, it has to be represented by means of an arrow. The length of the arrow represents the magnitude, where the direction of the arrowhead represents the direction of the vector quantity. Okay. So now we have already discussed this scalar quantity and vector quantity. Now let us discuss two very different types of vectors. One is called the position vector, another is called the displacement vector. Now first of all we will discuss the position vector. Now to understand the concept of position vector, a vector which gives position of an object with reference to the origin of a coordinate system is called position vector. Let me show it in a coordinate system so that you can understand it more properly. Here we have taken two axes, x-axis and y-axis, and suppose a point P is there, a particle is present here, or we can say an object P is present here. So we draw an arrow which starts from the origin and ends at that particular point P. The arrowhead is at the point P. The vector which is drawn here is the position vector of the object P. So now again I am reading out the statement here. A vector means this arrow which gives position of an object. It gives the position of P with reference to the origin, because it starts from the origin. So with reference to the origin, it gives the position of the body of a coordinate system. The coordinate system here we have taken XY axis is called position vector. So I think it is very clear to you. In position vector, you need to understand one thing, that the starting point of the vector is not relevant, because every time you use position vector for any particle, it will always start from the origin. Position vector always starts from the origin, that you need to remember. Okay. Now there are some properties of this position vector that you need to understand. It tells the straight line distance of the object from the origin. That means the length of the arrow, that is the length of the vector, actually gives the distance of the object from the origin. And secondly, what does it give? It tells the direction of the object with respect to the origin. That is, from the origin, in which direction we should move to reach that object. That is, the direction or the position of the object is given by the position vector. So I hope this is very clear to you. You can see here the angle is theta, so we can say that the object P is placed at an angle theta with the x-axis. So the position vector gives the direction of the object with respect to the origin. I hope this is clear to you. Now next is displacement vector. Now the displacement vector is that vector which tells how much and in which direction an object has changed its position in a given interval of time. As the name suggests, displacement vector tells about the displacement, that is the initial position and the final position of the body. Let us see through this graph. Again we take two coordinate system, x-axis and y-axis, and suppose the object is initially present at point P and at time t, and at time t dash it reached point Q. So these are the position vector at time t, and this is the position vector at time t dash. Now initially the object is present at P and finally it is present at Q. So the vector which starts from P, that is the initial position, and ends at Q, which is the final position, represents the displacement vector. Always remember that the position vector starts from the origin, whereas the displacement vector starts from the initial position and ends at the final position. As for a position vector, we were always sure that its starting position is always the origin, so it doesn't brings any relevance, because we always know that it starts from the origin. But when we consider displacement vector, its starting point as well as ends point becomes significant, because the starting point represents the initial position and the end point represents the final position. So I hope this is very clear to you. Repeat the video if you find that there is something which you don't understand. I hope that by repeating it you will surely get the point, but still then if you find any difficulty, you must post me the doubt so that I can clarify the doubts. Thank you.